right. I hope you guys had a good weekend. The weather's starting to get a little bit nicer. Um, and so hope you guys got some time outside to enjoy the weather a little bit. We're going to continue on with 12.5. This is part two. I'm just going to look at three examples here. And hopefully, if you need to rewatch it, that's fine. I'm hoping that's going to be enough here. All right. And so we'll just get into it. All right. We kind of did similar problems on Friday. If you go back and watch the notes or the videos and look over the notes, we're going to do some very similar type of examples, but I'm going to show you a different way to do it. All right. So we're going to use the idea of combinations from last week. But if you notice here in this first example, I wrote out, and just for this one, I wrote out what the coefficients would be if we were to expand this binomial to the seventh power, right? In the seventh row of Pascal's triangle, since our exponent is 7, these would be the exponents, all right? Now, I kind of briefly talked about this in one of the examples on Friday's video, but these coefficients actually are combinations, and it comes from these individual combinations here. So this is the connection with combination formula and Pascal's triangle, all right? This first term is 7 choose 0, okay? And when you work out that formula, all right, it turns out to be 1. This is 7 choose 1, right? When you can work out the formula or use your calculator, I guess, and you would get 7. 7 choose 2 is 21, etc., etc. And so what we're going to focus on is this, right? And just as a quick note, here's what the combination formula is, just in case. Okay, here it is in green. All right, this is the combination formula here. Or if you recall, also you can use your calculator to do NCR here. Okay. So this question says, what is the fourth term, right? And so just for this one, because we already have it laid out from the Pascal's triangle, the fourth term is going to be here 1, 2, 3, 4. This one here. And our coefficient is going to be 35, well, to begin with, okay? But what I want you to notice is it's the fourth term, right? Because remember, the rest of the examples, we're not going to use Pascal's triangle, actually, all right? The fourth term is here, but look at the combination format. It's 7 choose 3, right? And that's kind of important, okay? 3 is 1 less than this fourth term. Look at the third term, right? This is the third term, but it's 7 choose 2. The second term is 7 choose 1, and the first term is 7 choose 0, right? And so whatever term you're going to be asked to figure out, right? When you do the NCR formula, your R is going to be 1 less than whatever this term number is, okay? And so the fourth term, right, is going to be 7 choose 3, all right? Okay, so that's going to be 7 choose 3, all right? But let's pretend that we don't know that it's 35, okay? We're going to get rid of that for now, okay? And I'm going to show you the rest of the way here, all right? So we know for now it's going to be 7 choose 3, okay? So we're gonna work that out, right? The fourth term is 7 choose 3, which is, here's the work for it, right? Or you go to your calculator, okay? Do 7CR, and R is 3, right? And when you work that out, you should get 35, right? We already know that, okay? So that's 35. Okay, but here's the thing. How do we figure out the rest of it? Because we need the whole term, right? There's this y and this x involved, okay? Now, we remember from Friday's lesson, right? The first term, the exponents decrease, right? So meaning this first term here is 3y to the 7th, And remember, technically, x to the 0 power, right? And so this 3y to the 7th is going to keep decreasing, right? Well, if we're in the fourth term, that means my exponent of 3y is going to be 4 less than this 7, okay? I'm going to repeat that again. If we're looking for the fourth term, right, that means my exponent for 3y is going to be 4 less than 7. So that must mean that the 3y is going to be raised to the third power, okay? Because 7 minus 4 is going to be 3. Now what you also got to remember is, okay, well if this is 3, then for this term, remember the exponents here have to add up to the overall exponent. And so if this is 3, then this must be 4. Okay. Now what's in front of all that? The 35, right, from Pascal's triangle. Okay. All right. So then we work this out. Right? We have 35. We know this is going to be 3 to the third power. Right? I'm just going to show all the work. Right? This is 35 times 3 to the third and y to the third, and this is going to be x to the fourth, right? And so we just need to work out 3 to the third times 35, all right? And that's going to be what? 3 to the third is 27, right? And then 27 times 35, whatever that is, that's going to be your coefficient. So that turns out to be 945. So that's 945y to the third, x to the fourth. This would be the fourth term when you expand that out. Okay, so just as a quick recap, right? We are going to use these combination formulas, all right, and not use Pascal's triangle. Okay. We started by, it asked for what is the fourth term, and so we're gonna, whatever that number is, we're gonna do -1, and that's gonna be your R value, so 7 choose 3, right? So you can work this out or use your calculator, and that's gonna give you that coefficient, right? And then, since it asked for the fourth term, then we know that the first term in the parentheses, in this case 3y, right? That exponent starts with 7 as the first term, and then it's going to decrease, right, by 1 each time. And so if it's the fourth term, then 7 minus 4 is 3, right? And then the other term, this x, remember these two exponents have to add up to the overall exponent, all right? So let's take a look at number 2. Now, if you want to rewatch the example for number 1, go ahead, and then you can pause it here and try number 2 on your own, okay? Or you can just watch, all right? So what is the third term if you expand this? Okay, so I'm not going to use Pascal's triangle, all right? What is the third term, okay? This is my n value, right? 5, right? This 5 is n, okay? Now remember, if this is the third term, we got to subtract 1, so it's actually going to be 5 choose 2, all right? So when you do 5 choose 2, that's going to equal whatever this is when you work it out. I didn't bring my calculator down to my basement office, and so I just did the formula here, right? We know that these will cancel out, right? You end up with 20 divided by 2, which is 10, all right? So that's the coefficient, okay? So that's going to be 10, all right? Then we know that for 5a, okay, what is this exponent going to be? So if it's the third term, right, and if we start off with 5, then it's going to be 5 minus 3, which is 2. So that's going to be 5a to the second power, times, now you got to be careful, this is a negative f. Okay, so not just f, but a negative f, and this exponent plus the 2 has to equal the 5, right? So that's going to be 3. Alrighty? So then we work this out, right? This is going to be 10 times, this is going to be 5 squared, so that's 25a squared, times negative f to the third, right? If you have a negative raised to an odd exponent, that's going to be negative. So what I'm actually going to do is that negative I'm going to bring out to the front, okay? So that's going to be a negative 250a squared f to the third power. So this would be your third term, right, if you were to expand out this binomial. Okay, so negative 250a squared f to the third, okay? Now I'm going to pause here real quick before I go to the last example. If you want to use Pascal's triangle, that's fine. Okay, I don't think I'm going to limit you on the quiz. You can use the Pascal's triangle. If you want to use the combination formula, that's okay too. All right. Now for this last example, it's just asking for what's the coefficient. Okay, just the number. For the term that has m to the third p to the sixth. Now we know this makes sense because, look, 3 plus 6 is 9, and 9 is the exponent here. Okay. So let's take a look here. So I'm going to start off with, if it's m to the third p to the sixth, right? That means that eventually it's going to be 2m to the third power 3p to the sixth power, right? But we need that coefficient in front, right? If you were to go to Pascal's triangle, you can use the ninth row to figure that out, right? But in this lesson, I'm focusing on the combination formula, right? And so, well, if it's to the third power, right, this one must come from 9 choose 6, right? Because if it's to the third power, and if the degree is 9, if the highest exponent is 9, then that means 9 minus what is 3. Remember, because that first term, the exponent is decreasing, right? And so it's got to be 6, right? Because it went down to 3, so that comes from 6, all right? So you work this out, 9 choose 6 in your calculator, and you should get 84, I believe, okay, if you work that out, or if you do it on the calculator, okay? So the thing is, it's not just 84, right? That's the coefficient from Pascal's triangle. You got to take into account of working 2 to the third out and 3 to the sixth, okay? And so in actuality, this is going to be 84 times 2 to the third times 3 to the sixth. Okay, so you work that out here. All right, you need a calculator, okay, and you're going to get all of this, right? Okay, some calculator work here. Your actual coefficient is 489,888. Okay, so when it asks for just the coefficient, all right, so I'm only doing one example of this one. If you need to rewatch it, then please go ahead and do that. I'm gonna try to put up some solutions for the practice sheet that I'm gonna put up in Google Classroom tomorrow for 12.5. Maybe a video or two of some of those problems, and so or a video of one or two of those problems, and then we'll probably do a Google Meet sometime later this week. All right. Hopefully that helped.